Okay, let's see if we can get this to actually work on the first try here. So as you can see, well, I have a bunch of windows open. I have some turned off, as you can see in the camera in the background there. What we have here is the Arduino Wi-Fi Rev2 connected to an ultrasonic sensor for distance, to a simple temperature sensor, the DHT11. We also have, well, we're only using one of the relays, but we actually have a dual relay board here. And we have a stepper motor with a little squishy Mickey on it. Okay, now we have Unity, just a quick Unity interface just for a couple of the basic ones. So just to start off, we can, let's see if we can aim this a little bit farther out so I can put my hand in front of it. So here we'll get distance. It's sending a signal to Pubnub, which sends it to the Uno, which sends it back to Unity, gives us 39 centimeters. So if I put my hand in front of it and get distance again, you can see it's only 3 centimeters. So the sensor is working. This is the Pubnub window that you see on the left. So you can see it's sending the command get distance, and the sensor's reading it and coming back. So we can do the same thing with temperature. So you'll see in the Pubnub window, when I press temperature, it'll get the command and it will respond. Okay, and we can do the humidity. Now within Unity itself in the code, we can do the conversion to get Fahrenheit if you actually need it. We don't have it right now, but it can easily put in there. It's just a formula. It saves some coding space on the Arduino itself. So you try to do as much as you can outside of the Arduino and just use it to actually run the actual sensors. So okay, so we have those two working. Now to get the other ones, the other two to work, we have to actually use the Pubnub interface since we didn't code it into Unity yet. So give me a second to remember what the other ones are. We have toggle light. So that's toggle light. Now if I type in toggle light as a text message, it'll go from Pubnub to the Arduino. It should flip on the relay, and then that should do it. Okay, it should have flipped on the relay. Did I disconnect something? We lost Mickey. Oh, I forgot. I know what I forgot to do. Sorry. It actually needs a random command at the end. The comma and random command that actually acts as a timestamp. So in Unity, we have it randomizing a timestamp. So in this case, we have to manually type one in. There it goes. That's what I did wrong. I just forgot to add the extra timestamp. Now, if I try to run the command again, it says OK, toggle light OK is what I typed in. I do it again. What happens is you can't see it, but in the back end on the Unity side, or on the Arduino COM side, it's saying repeat command. So if I were to type like OK1 and do it again, it turns the light off. So it's just toggling the relay, which will activate the contacts, which you can plug anything you want. You can do a fan, whatever. We just figured putting a light onto it would work. Okay, so let me see here. We have that. We have get distance, and then we have a rotate stepper motor. So all right, so let us rotate step motor. Did I spell that right? No. Step motor at, and I believe it's speed colon how many steps you want it to go. I believe that's what it is. So now we need to change the command here to make sure it's not a second command. And just in case it works first try, let's hold it here. And we'll set Mickey on there. And it's not working first try. I must have it backwards. The lights came on the motor, as you can see, but it didn't seem to want to go. Let me check the code real quick here. I forgot exactly what the command was. I know it was, is it just rotate step motor? Sorry, I'm going through all the code here real quick to find that. Then we got parameter value, so that's the fourth one. It's steps then speed, it looks like. Okay, so I wanted to go 100 steps, not 1-0. 100 steps at a speed of 4. And we'll change that again, and we'll hold it. There he goes. He didn't spin very far. But that was only 100 steps out of 2,000, so let's go 1,000 steps. Just change that number again, and we will go 1,000 steps at speed 4. There you go. Okay. So we actually have everything working. Let's see, I can close down the Unity. I will turn on the Arduino code and make that slightly bigger here. So what's actually happening, so we'll just, oh, it's not available because I don't have it plugged in. That's right. It's not plugged into the PC. So we're using a bunch of libraries. The important one is the Wi-Fi Nina. There's also a Wi-Fi 101, Wi-Fi 1010. Those are for different boards. The Rev2 uses the Wi-Fi Nina. Pubnub based client is Wi-Fi client. Now, in order to get that to work, you must go into the Pubnub H defs library and change. They have Pubnub based client, Ethernet client. It's not Ethernet, it's Wi-Fi. So once you change that to Wi-Fi, suddenly everything will start working. So you can see we got our defines up here at the top. Just doing the DHT, which defines the temperature sensor. Stepper motors, it's steps, which is defined as 2038 up top, and it must use 8, 9, 10, and 11. Those are the pins. Everything says to use those pins. I guess there's something locked into those pins that controls it, but it works. Okay, so then we have the wireless. I changed those here, so I put change on the things you need to add yourself. So you add your SSID and your password for your wireless network. You add your publish key, and this is actually a subscribe key, not the publish key. So that's what you actually want right there. And let's save that before I forget. And then the channel you want to broadcast on, like on the window, I'm broadcasting on, let's see if I can. We are actually on the IoT channel, which is what we set here in the change channel. And then the change Arduino is here in settings under client, the client UUID. So you can have multiple things on different channels, etc., using the same pub sub keys. So the unassigned long time, all that good stuff, we'll just quickly go through here. So these are where we list all our commands that we set up. The toggle light, get temperature, etc. All our declarations. Now we initialize the serial port to operate, so we can actually click this little serial monitor here and see what's actually going on and watch it happen, which I can't because, as you can see with the board here, I'm using an external power supply. And this board here, which supplies 5 volts down here and 3.3 on the top, and then I take the USB cable and just plug it in to power the Uno, or the Wi-Fi Uno, whatever. So it still only needs the one power supply. It's still low power. It just supplies a little bit more than the Arduino can get through the USB port. Okay, so then we're setting the trigger pins and echo pins for the sensor, the relay, all that good stuff. Now we have a Wi-Fi connect. This actually connects to the Wi-Fi, and there is a loop that will check for your Wi-Fi connection. So when the Wi-Fi connection drops, within 3 seconds, as long as there's a Wi-Fi signal that you're set to connect to, it should pick it back up and connect. Because we have had issues with it dropping offline from time to time, and that fixed our problem. So sometimes you may have to run a command twice, but that's because you may have ran it in the between time of picking up a signal. So this is all the Pubnub stuff, the read message, and then we split the message so that way we have the message block and the command ID, things like that. So I'm sure this will make sense to a lot of you and absolutely no sense to others. This is where we're setting up the array, telling it which to run. And this is where we compare the input that we're sending in. And then we have the actual methods. Void toggle light, send temperature, send humidity. So in read distance, this is what happens after you hit the command. It goes to Pubnub, it sends it back to the Arduino will run whatever it's called here, and then when it's done, it runs the send message to send the message back to Pubnub, which will either push it out to Unity, you can push it to a wireless device or phone or email, or just let it go to the console, the debug console window. And there we have it. This is our basic Pubnub setup. So here we are testing the Wi-Fi connection and the Wi-Fi Connect that it runs. We don't truly need to scan SSIDs since we're using a named one, but it is best to keep it in there just in case. And then this will print out the Wi-Fi status, because we were having issues and we wanted to make sure that it was online, so every time it reconnected it would let us know and tell us what was going on. Now for a production case, what we would do is go through and either comment out or more than likely remove all these prints and print lines. They just take up space. There's no need for them, and if the thing's going to run in the field, you're not going to have a video connected to it or anything, so you're not going to need to take up this space and use these extra commands. Since you are limited, when you run this, come on, you can see that it's using up 51% is total everything here, but some of that is actually just running all these print commands. Everything we do has a print command on it. So anyway, I know it's a little boring, but you can see that everything here works. We got the relay to work, we got the motor to spin, we got the distance sensor and the temperature, and you saw it work within Unity as well as using Pubnub directly. So don't know what you want to do with it, but have fun. Bye.